Higher level GCSE math students, make sure you can answer 3D trig and Pythagoras questions like this in case they come up in your paper 2 tomorrow. So with these 3D trig and Pythag questions, what you need to understand is it's exactly the same steps and techniques that you know for two-dimensional trigonometry and Pythagoras. So what we need to do is we need to think about what it is we're trying to find and break the problem into a series of two-dimensional trigonometry or right-angle trigonometry and Pythagoras theorem problems. So we're going to start by looking at what it is we actually want, right? So in this question, we want to work out the angle that BE makes with the plane ABCD. So I'm going to go ahead and draw in this line BE. And what we're going to do is we're going to look to form a right-angle triangle within this prism here, such that we know that we could use right-angle trigonometry to find the angle that we're interested in. And so you can see that what I've done here is I've identified a right angle triangle that lies within this prism that contains the angle of interest, right? This angle here is precisely the angle that BE makes with the plane ABCD because, it's sort of the angle that it makes with a line that lies beneath it that, lies flat within that plane, which is the line DB. So, I have a right angle triangle, and now I know that if I know two of the side lengths in a right angle triangle, I can use right angle trigonometry to work out any of the angles that aren't the right angle. And I know one of these sides, right? This is ED is 2.2, so I can put this in. So what that means is that if I can work out EB or DB, then I can use right angle trigonometry to work out what I want. So how would I go about working out DB? Well, I need to identify another right angle triangle. And you can imagine if I look sort of with a bird's eye view down on this prism, there's a right angle triangle that lies in the base, and I'm going to go ahead and draw that out now. So now I have this right angle triangle here, ADB. I know that this length AB is 6 centimeters. So again, if I was somehow able to work out this length here, AD, then I could use Pythagoras theorem, okay, so, a squared plus b squared is c squared, to work out what dB is, and then I would have the same dB, right, it's the same dB in both these triangles, and then I could use, right angle trigonometry to get what I want. So again, it's, you can see how it's useful to sort of break this down and start off with thinking at the end what you want, and see kind of, what would I need in order to find that out, and you kind of sort of follow it backwards to get what you need. So then the question is, well, how can I work out AD? Well, if you look at this diagram here, I have another right angle triangle, and I can again use right angle trigonometry on to work out this length AD. So let's go ahead and copy that one out. So now I've drawn out this right angle triangle, and again, you don't really have to draw any of these out, but it's just to help break this down and make it really clear for those of you who want to see it done like this. And we said that we want to work out AD, so we can use right angle trigonometry. And again, I'm going to go through that very carefully. So, I want to think about what sides I have, what sides I'm trying to find, etc. So I have my opposite, and I want to find my adjacent side. So the relevant trig function, you can write out SOHCAHTOA if you want to. So you could say, okay, SOHCAHTOA, and write it out like this. And then, the one that sort of has the side that we know and the side that we're trying to find. Okay, so that's, this one here. So we have this and sort of trying to find this, etc. This is going to contain the trig function we want to use.